So we're going to go over soldering, both surface mount and through hole, and some tools and tips and tricks and that kind of thing. If you are already a pro at soldering, you can just skip this, but you might learn a thing or two. And at the end, we'll be doing another video, which is soldering together a board that I'm going to be giving you with components and showing you, walking you through how to do that. So why are we soldering? What is soldering? You're basically connecting two pieces of metal, whether that's a wire to wire, wire to component, component to board. This is an example of soldering a component onto a board. This is an example of soldering two wires together. It creates both a strong, both electrical and mechanical connection. So you tug on those wires, they're not going to come apart, and then also current can flow between them easily. Some terminology to go over quickly. Solder is the metal melted to join the two metal parts. So what you're going to be pouring over things to connect them. Tinning is when you cover a pad or a wire with a layer of solder preemptively before you are attaching it to anything else. Flux is a sap-like material that cleans and prevents oxidation, which makes soldering easier. Oxidation is when the outside of the metal gets oxidized, it turns a different color and is harder to work with. It reacts with the oxygen in the air. And then rosin is like a rosin core for solder, which basically you just like have kind of flux inside of the solder. Some tools we're going to be using. So first things first, soldering iron. It looks like this is the very tip of it. It's a heated metal pen-like tool that melts solder and heats pads to be soldered. So anything you want to heat up, anything you want to heat up to be soldered, you're going to be using that soldering iron for that. A heat gun. If you can place solder or solder paste on a pad and place the component on the pad and basically blast with hot air, it makes it sometimes easier to place SMT parts, so surface mount parts. You can just heat up the solder and do a bunch of pins at once as opposed to individually soldering every one. It's also good for heating up like heat shrink if you want to cover a wire, for instance. It just blows hot air. Solder sucker and solder wick are both tools that remove excess solder. Solder sucker does this by like literally sucking up the solder, and then a solder wick is like braided copper. This achieves the same purpose. You put it on top, it sucks up the solder, and that's good for unsoldering things or if you put too much solder on your board. So how do you actually go about soldering? You're going to want to heat up the components before you apply the solder. You're going to want to heat up the components that you're soldering, so the pad and the wire or the component or whatever you're doing with the soldering iron. A common mistake is to take the soldering iron, melt solder onto it, and then just wipe the solder onto the pad. This will result in a cold solder joint, which we'll go over in a second, but don't do that. Heat up the components first. Wait till the solder flows over the component cleanly, then remove the solder, so remove like the little wire that you have, the little metal, and then remove the soldering iron. If you do it in the opposite way, basically the solder will get stuck because it will cool down immediately, and it will get stuck to whatever component or wire you're attaching it to. Happens all the time, but that's the order. So going over some tips and things not to do. So this is a great diagram, I think. Basically, yeah, heat up the part in the pad, then add the solder, continue heating until it flows over it, and then just let it cool down. It should look like this if you're doing a through hole component, for instance. It should not look like this. This is kind of a sign that you've like wiped solder onto something. It means that the pad was not heated up, so you just wiped the solder onto the component and it didn't properly solder. So it's not on the actual pad. This will not be a good electrical connection. And that's called a cold solder joint. You also don't want to have too much or not enough solder. Too much, you can't actually tell if you did a good job or not. This could just be a giant bubble over it. It's not a good connection. And you don't want to have it enough because then it's not making a good connection also. You can use either solder wick or solder sucker to remove too much solder, and here just can do this again, add more. Make sure you don't short components. Sometimes if you put too much solder on, you can basically create a connection between two components that should not be connected. And then if you just heat it up too much, this doesn't happen a ton, but if you have it's too hot or you leave it on for too long, it could look like this, and that's not ideal either. So this is what we're looking for with through hole components, and it's a similar thing with surface mount as well. You're going to want that kind of clean edge. So soldering iron tips, tons of different options. It doesn't matter what you're using for this. If you are doing like really tiny components, like what we're doing with this board, a smaller tip is easier. Something like this or this, it's easier to get onto that component. But if you're doing something large and it has like a metal chassis or something, it can be hard to apply enough heat at one time to heat up the component before it cools down further away from where you're applying the tip. So then it would be more useful to use something like this or this with those big metal components to be able to apply enough heat. Sometimes a soldering iron has like an easy swap tip where you can kind of just pull it in and pull it out, but sometimes you have to wait for it to like cool down fully, which can take a really long time before switching up the tip, or you'll burn yourself. So that's kind of annoying, but we deal. This is a really cool tool. These are like soldering tweezers, and this is really great. Like if you have a resistor or something that has two sides, you can solder or unsolder the whole thing all at once. And you might see in the future this is annoying if you screw something up like that. This is a great tool if you can get one. Okay, most importantly, safety. You're always going to want to wear goggles while soldering. Solder can basically like jump up and hit you in the eye because it's hot, it's bubbling, and we don't want that. That can blind you. If you're working with solder, you're touching the solder directly, wash your hands before you eat. Solder often has lead in it, so you don't want to eat lead. That is bad. Assume the iron is always hot. Don't be like this guy. First of all, he's not wearing goggles, and he's grabbing the soldering iron by the tip, which is metal and 400 degrees. That will burn you. Don't be this guy. He's clearly not actually soldering anything. Yeah. Try to have airflow in whatever room you're working in. If you have like a fan or open window, that helps. The fumes can kind of give you a headache or make you sick, and it's not great. So just try to have some ventilation. And do not solder while the circuit is powered. If you have if you accidentally short something or do something, you can cause problems to your circuit. You can, cause sparks or worse. So just don't do that while it's powered. Just turn it off before you start soldering. Don't try to live fix things. And the next video will be a video demo. We'll be walking through how to solder this clock tower PCB, which I will be getting to you guys as soon as possible. All right, thank you.